Alright, this video is for our lecture this coming Thursday. This is section 7.3, and it deals with determinants. Right. Couple of definitions to start off with. First, matrix. A matrix is an arrangement of numbers in rows and columns. A matrix is like a table with the labels stripped off of it. Here's an example. We typically will see a matrix listed in brackets like this. Maybe we have the numbers 2, 3, -7, and then 1, 4, and 2. Rows run horizontally and columns run vertically. We talk about a matrix in terms of their dimensions, and the dimensions are the rows by the columns. Rows by columns. Okay. RC, like RC Cola. Rows by columns. So this matrix has 2 rows and 3 columns. Thus, we would call it a 2 by 3 matrix. 2 horizontal rows and 3 vertical columns. All right. Next, definition determinant. A determinant is an operation on a square matrix. And a square matrix is an n by n one. Now, as you would imagine, the same amount of rows and columns. Looks like a square. Okay. Examples. Alright, or I should say definition, really. For a 2 by 2, okay, a 2 by 2 matrix, the determinant looks like this. First, you have instead of the brackets as we showed previously, we'll show the matrix inside these straight bars. Looks like absolute value symbols. All right, and it is indicating that we are to take the determinant. The determinant of a 2 by 2 matrix is simply going to be this diagonal multiplied together, 7 times 1. Well, 7 times 1 is 7. And subtracting this diagonal multiplied together, 3 times 5. Alright. 7 minus 1 is 7. 5 times 3, that's 15. And 7 minus 15 is -8. So this matrix that would be a 2 by 2, when I place these bars outside the matrix, it's indicating I want to do this operation. We simply multiply this diagonal, and we subtract. The first part of the subtraction is this first diagonal. Really very simple. All right. Slightly more complex is a 3 by 3. 3 by 3. Okay. Again, the bars indicate we're finding the determinant. 1, 7, 9, negative 2, 5, 4, 3, 8, 6. I've purposely made all of the digits different. Your matrix does not have to look like that at all. All right. Again, it's going to be some diagonals, and this is going to look perhaps slightly convoluted, but it's not too bad. We're going to multiply this first diagonal together, 1, 5, and 6 equals 1 times 5 times 6. Okay, and we're going to add this next diagonal, but now we have 2 here, and we need to pick up this 1 that's down here. All right, 7, 4, and 3. 7, 4, and 3. Then one more set of numbers here. Well, you see we went this major diagonal and this next one and picked up this one. Well, then we're going to start with this 9, and you guessed it, we're going to pick up this 8 and negative 2 down here. So I'm picking up 9 and negative 8 and 2. Okay, so you can see in each case we've used 3 numbers. This diagonal, these 2, and then this one, and then these 2, and then this one. All right, so the last one is 9, negative 2, and 8. 9, negative 2, and 8. All right. Now we're going to do some subtracting. What are we going to subtract? Diagonals the other direction. Okay. We have to subtract each one of these elements. So here I go, looking in this direction. 3, 5, 9. 3 times 5 times 9 minus this next one, 8, 4, and then pick up this one element over here, 8, 4, 1. 8, 4, 1. Then lastly, 6, and then these 2, 6, negative 2, and 7. 6, negative 2, and 7. All right. Then I'm going to leave that arithmetic to you, but you can certainly multiply each one of those out. I'm now going, and I believe the determinant here is negative 113. Okay, now we're going to look at a couple of problems from our homework. Our homework for this section, 7.3, will be page 515, 1 through 10, all, and then 11 through 25, odd. All here, and then odd here. Okay, so looking at problem number 1, it gives us the matrix 1, 0, and 2, 3. I guess I misspoke calling it gave us the matrix. It's asking us for the determinant. We write the matrix with the braces, the brackets, 1, 0, 2, 3. This is a 2 by 2 square matrix. When we replace these little symbols on the side, it's asking for the determinant. It's asking for this operation. We will multiply 1 times 3, this diagonal, and we will subtract 2 times 0. 1 times 3 is 3, 2 times 0 is 0. This is 3 minus 0, and this is 3. That is your answer. The determinant of this operation yields 3. Okay? The determinant of this matrix is 3. All right. That will take care of 1 through 10 entirely. I didn't ask for 11 through 25. Now I'm skipping on down and looking at number 24. Okay. 24 is a 3 by 3 matrix. You are doing 11 through 25, so I'm doing 24. This will help you with 23 and 25. All right. 24 says -1, 0, 2, 3, 0, 1, 0, 1, and 3. Okay. It says to use method 1. The book introduces a couple of methods. I'm just showing you this one particular method. I think it works just fine. All right. So we're going to take one set of diagonals. -1, 0, 3. -1, 0, 3. Now, these two and this one plus 0, 0, 1. They have a lot of zeros in this matrix. That's going to be very helpful for us. Plus this one and these two. 2, 3, 1. 2, 3, 1. All right, I'm going to show again how I connected them before. 2, 3, 1 right here. 0, 1, 0 here. And each time we're simply collecting 3 elements, and there's really only one way this goes down. These 3, then these 2 and this one, and then these 2 and this one. So really, it's while it might look a little tricky in the beginning, it's pretty straightforward. All right. Next, we're going to subtract, going in the opposite direction. 0, 0, 2. Minus 1, 1, -1. And then lastly, 3, 3, and 0. All right. This one works pretty quickly because of so many zeros involved. Here's zeros involved in this multiplication, that's 0. 0 in this multiplication, that's 0. 1 times 3 times 1, that's 6. We have 0 plus 0 plus 6. Down here, 0. 1, 1, and -1 is -1, but minus a negative is plus 1. And again, 0. Okay, so we're left with 6 plus 1. The determinant here is 7. Alright. With that, you should be able to handle most of the assignment. Now I'm looking at the middle part, the 11 through 22 section. We're going to have to solve some equations. I'm looking at number 18. You don't have to do 18, but this should help you with a couple of them adjacent to it. Should help with all of the ones beyond 17. 18 gives us x squared, -2, x and 1, and they say we are equal to 35. So what we're going to see here is we're going to arrive at a quadratic equation. All right. Multiplying this times this, x squared times 1, minus this times this, -2 times x. And this time we have what it's equal to. It's equal to 35. So now you can see we're going to have an equation here. X squared times 1 is x squared. -2 times x is -2x, but minus that becomes plus 2x. And we have equal 35. Okay. So now we're going to have a quadratic equation. We've learned a few different ways to solve these. I'm going to show completing the square. All right. X squared plus 2x plus some box number is going to equal 35 plus that same number. If you want to use the quadratic formula or you want to use factoring, you give it a shot. I'm showing completing the square. 1/2 of 2 is 1, adding 1 to both sides. Now I factor this as a perfect square. 35 plus 1 is 36. The square root of x squared goes first. The square root of 1 goes last, or half of this, whichever way you want to look at it. Quantity squared. Now I take the square root of both sides. I'm going to skip down another line and just show taking the square root of both of these. X plus 1 squared, the square root of 36. Alright. The square root cancels the square. They're inverse operations to leave only x plus 1. I don't need the parentheses. The square root of 36 is both plus and minus 6. Alright, now we have two equations. X plus 1 is positive 6, and x plus 1 is negative 6. Subtracting 1 from both sides gives us x is 5, and subtracting 1 from both sides gives us x is minus 7. Alright, those are your two solutions. X is 5 and negative 7. We could substitute that back into the original, but you'll see it will satisfy it. In fact, let's go ahead and do that. X is 5 and negative 7. Coming back to we're going to look at x is 5 and negative 7 and see if this satisfies our determinant. Okay. If x is negative 7, well, negative 7 squared is 49. 49 times 1 is 49. Negative 7 here. Negative 7 times negative 7 will be a plus 14. Well, 49 minus 14 is indeed 35. Negative 7 works. Now I'm looking at 5. 5 squared is 25. 25 times 1 is 25. 5 times negative 2 is a negative 10. But 25 minus a negative 10 is 35. Both of these are good. Okay. With this information, you should be able to solve all the rest of the problems on this assignment.